pretty tough. Okay. Now the expectation is at the end of class today, I'll show this again. I'm going to give you 6 problems to try out tonight. Tomorrow, you already know if you got them right or wrong, and you got help on them, whether it be through the answer key or the guy that does the video answers. All right. What's our plan for the Regents exam with the calculator?
The calculator? I have one.
Okay. You might want to start using it now because I can't answer any questions on it. We all ready to go? Okay, here we go. Probably, and I know some of you will be devastated to hear this, I don't have time for the numbers anymore. Either you're focused or you're not. Okay? I don't have time to call on you and try to catch you if you've been paying attention or not. We got to get through all this. So number 2 is the first one I assigned last night. It says, which one's true for all real numbers? Plug numbers in. Store. If you can store numbers in on any of these problems, do so. And again, I try to avoid storing in zeros and ones. So you pick a random number, 2 for X, 3 for Y. Tell me now, do I need to review how to store? We're all good on how to store. Okay, and then it's pretty simple. You take choice 1, you plug in the left side. X minus Y all squared, the calculator will generate a number. Then you do the right side, X squared plus Y squared. The calculator will generate a number. Are they equal? If they are, this one's good. If they're not equal, that one's not good. And then you do the same thing for choice 2. Done. Okay? Everybody good? All right, I don't have time to stop and store, but that's how I would do this problem. I would not try to do X plus Y to the third and see if it's equal to that. I would just store 2 random numbers that aren't 0 and 1s and see if the left side is equal to the right side in both of them. Okay, any issues there? I'm going to go quicker through some of them than others. And you would notice that both of them do not work when you stored. Okay, both of them don't work. Sorry. All good. Okay, here we go. Number 5 I assigned. Okay, you're going to do a 7-year lease. You start out with $85,000 for the first year. Every year we're going to increase it by 6%. In the 7-year window, how much did you pay? Okay. If I had to, I'm going to show you the way I'd like it to be solved, but if you had to, we could do this. All right, year 1, how much did you pay? $85,000. Right? How would you, if you had to do this, how would you find how much you're paying in year 2 if it goes up 6%? Multiply by? 0.06 and add that to okay, multiplying it by 0.06 just won't do it. You got to add it to 85,000. If you didn't want to multiply it by 0.06, anybody know what you multiply it by to get to? 1.06. So I can multiply that by 1.06. I get year 2. And then, all right, yeah, great. Here we go. 3, 4, 5, 6, 7. And then add them all up. If I had to. You're there for 3 hours. Okay? You're there for 3 hours if you had to. And add them all up. Everyone good there? Old school way. All right, how would I like you to do it? This is a sequence you're setting up right now. What are you doing to get to year 2? Well, what are you doing with the 1.06? What are we doing again with the 1.06? Multiply. Multiply. What type of sequence is it where I multiply? Arithmetic or geometric? This is geometric right here. Every test I've printed out for you has a reference sheet on the back. Take a look at it. Because this is geometric, and there are 2 formulas on the back of your formula sheet for geometric. Everybody see them. One says geometric sequence, which means I find a certain term. And series is for, anybody remember what I use series for?
When you have to add them together.
Add them all up. So you tell me in this problem, am I finding a certain term or am I adding them all up?
Series.
I'm adding them all up. So I want to use, everyone look. Everyone see where it says geometric series on the reference sheet. Look at the reference sheet. Everyone see it. I'm coming strong. All right? Because I'm not going to see below 65s on here. Everyone see where it is. We're all good there? So it's going to be A sub n or S sub n equals A1 minus A1 r to the n over 1 minus r. Here we go. Got to figure out what to plug in now. Everyone remember what A1 meant?
First term in the sequence.
First term, which is 85,000. Minus first term, 85,000. Anybody remember what R was called? It started with an R. Ratio. That's what you multiply by. We already found that out. What do I multiply by? Now, okay, hey, not 0.06. It's not 0.06. You add 1 to it, so it's 1.06. And a quick question before we finish this. What if it says decreases by 6%? I wouldn't put 1.06 in here. Why 0.94? Where'd you get that, Spencer? You subtract it from 1, okay? So decreasing is 1 minus the rate. Increasing would be 1 plus the rate. Good. N value is how many times I'm going to add up. 7 terms. All over 1 minus, what was our R value? 1.06. Here we go. Fraction template, fraction template, fraction template. Do not try to do this piece by piece. All right, fraction templates. That way, when you use a fraction template, you can just plug it right in. And you should end up with, hopefully, choice 4. So using the formula sheet or old school, keep multiplying by 1.06, add them all up. The only time I worry that this method right here would cause you issues, 25-year lease, 50-year lease, something where it's just out of control, where you're like, I'm not going to spend all that time finding it. But you could. I guess you got 3 hours, right? So I guess you could. All right. Questions here?
Isn't there like another way that we learned last year?
This is the exponential growth or decay.
Yeah. Is that how you'd answer that too?
Would that, okay, that would find you at the 7th year, how much you're paying, but it wouldn't add it up for you. Okay, yes, you are correct. It would find you like how much you would pay the 8th year in the rental. All right, but it wouldn't add it up for you. Okay. 7, here we go, 7. Which statement is true? This one's a tough one because you did this so long ago in Algebra 2A. X minus 1, X plus 1 is a factor. Okay. All right, let's see if you remember this from last year. Let's say I was going to divide it by X plus 3. Okay, do you remember how to find what the remainder would be? I'm going to divide this P of X by X plus 3. Do you remember how to find what the remainder would be quickly without doing synthetic or long division? Anybody remember? Going to take a try, Ben? Well, that's how I would write it. What I'm asking is, what is the remainder when I divide by X plus 3? Anybody remember that or no? Okay, that's fine. You take the opposite, X plus 3, what would be the solution? X equals -3. You would take -3, plug it in for X, and whatever number you get out, you get the remainder. Okay, that's how that worked. Okay, everybody good there? I'm telling you this because that helps us in this problem. If it is a factor, the remainder should be equal to 0. Okay, if it's actually a factor, there should be no remainder. It goes in evenly. Okay, if it's a factor. So I can automatically eliminate choices 1 and 2 because they come out to be 2 and 2. Okay, so if it's a factor, the remainder equals 0. Now take a look at 3 and 4. Bless you. What is the problem with 3? If you want to know if X plus 1 is a factor, why is 3 incorrect, even though it comes out to be 0? Remember what we just went over. If x plus 1 is a factor, what would you plug in? Remember, if x plus 3 was a factor, what would I plug in? X equals? I'd plug in the opposite. Are you plugging in the opposite here with number 3? No, you're plugging in the same thing. Everyone see that? I always plug in the opposite. So if x minus 1 is a factor, I'd plug in 1. 1's equal to 0. It's a factor because there's no remainder. Okay, no remainder. Well, I got to find more of those to do. Anything you want to ask there? Okay, I'm hoping the next one, though, you're going to be pretty confident in. 11. Completely factored. What is it? If you guys are frozen, try to eliminate a response. In this case, it says the completely factored form. One of these choices is not completely factored. You can factor it a little more. Which choice is not completely factored? 1, yeah, n squared minus 9. So you know that at least you just went from 25 to 33% chance, if you had to guess. All right, so how do I factor this? Any GCF? Look for a GCF, kids. Any GCF? Nope. Count up the terms. How many? 6, even number. You got an even number of terms, you can group it. Odd number, whew, we'll have to get to that, but even number of terms, we can group. All right, let's have some fun. What do you want to take out of the first one? N squared. What's left? N to the second minus. Good so far? Now you're crossing your fingers. Hopefully everything else comes out to be n squared minus 9, right? Next one, second grouping. 4 and an n. And yes, we are left with n squared minus 9. All right, now you got to be careful on this next one. I want an n squared minus 9. What should I be taking out? What type of 12? Negative. Yeah, you can't take out. If you take out 12, you'll be left with negative n squared plus 9, the opposite. So you got to take out a negative 12. And what's that? Minus 9. Yep. Okay. How do I finish grouping? N squared minus 9 gets taken out. And then in the other parenthesis is everything that's been left over. So what's left over here? N squared. All in the same parenthesis. Minus 12. And then, yeah, we can go one more time. N squared minus 9. Plus 3 and minus 3 looks good. Ooh, now you're going to find two numbers that, help me out, multiply to negative 12, but add up to 4. And remember, this is multiple choice, so if you're struggling right now finding those numbers, look at your choices that are left. Yeah, it's got to be 6 and 2, right? According to those choices. I just got to make sure I put, now here I got to do on my own is put the proper signs. It's got to add to 4. Plus 6, minus 2. Yep. There you go. Choice 2. Not bad. Remember, 26 points to get to 65%. 24 multiple choice. 24. They're worth 2 points apiece. How many are you going to have to get right out of 24 then to hit your 26? 13 out of 24 multiple choice. So you don't have to worry about parts 2, 3, and 4. All right, but this right here is tougher, easier said than done. Anything you want to, we good here? 16. Okay, what's the number? Now, you could, without doing anything, take each, so you could take 10, ready? And go 10 minus 20 times, what's the reciprocal of 10? 1 over 10, and you could say, hey, does that equal 8? You could do that and go through each choice. I'm fine with that. I'm fine. But for me, I need to make sure if this came up in part 2 or 3, you know how to do it without just plugging in random choices. Okay, but everyone okay on that's an acceptable way. Nobody's going to look at your work on multiple choice. All right, so how do I do this? Here we go. A number, what do you want to call it? Minus 20 times its reciprocal, 1 over x equals 8. And again, everywhere you see an x, plug in one of your answers and you're good, but I want to solve this. All right, even if you're wrong, who cares? You're trying. Where do you think you want to go from here? First of all, what don't you like looking at up there? The 20 and the 1 over x, right? Okay, can you combine them into 1? Because all you're doing is multiplying. What's it going to look like? What do you think? 20 times 1 over x. How do I rewrite that just as one fraction? 20 over? Yeah. Yeah. What do you still don't like about it, guys? Still a fraction, right? Can we get rid of the fraction? What's in the denominator? How do you get rid of that x in the denominator? Yeah, multiply it by x. Uh-oh. It's unbalanced. You got to get love to everything else. You just can't multiply this one by x. You got to make sure you give love to everything else. Whatever you do to one, you got to do to the rest of them. All right, you take over now. What do I end up here with? They don't cross out. X squared. Okay, these are minus equals. Now you're going back to your Algebra 1 days now. Yeah. What do you got to do next? Set it equal to 0. Yep. Now, hey, you're moving, and I'm doing this in all seriousness because I don't know what you're going to write down. When you move over 8x, try to put it in the correct order. Don't do minus 20 minus 8x. That's just going to mess with your mind. Minus 8x minus 20. All right, same thing we just did last problem. Multiply to C, add to B. And you guys know what the numbers are because you're looking at your multiple choices, which I like. No cheating there. What are my signs, though? Got to add to negative 8x minus 10 and, yep. So x equals 10 and there we go. Got to show you how to do it this way in case you have to do it on part 2. 10 and negative 2 choice 1. Anything here? All right. I think I went to a part 2 question next. Yep, 25, 2-pointer. Part 2 is where also you can add in some points very quickly because these 2 pointers aren't that bad. Okay, great. Temperatures, hours of daylight for each month. Average rate of change from January to April. Yep, what's my formula? Second time we're doing this now. Second time. Y on top, change in the Y's on top over the X's on the bottom. Now the issue is, where do I get those values? Because I'm going to have to subtract, but where do I get them? Y values, what do you think? I got that table, right?
Yeah.
And where am I going from? January to December, yeah, that's what the table is, but my rate of change is to from January 1st to April 1st, right? Where am I going to put that 13.9 and 9.4? That's my y's. Those are my y's. 13.9 minus 9.4. Yep. Ooh, what about on the bottom? What else could I? Remember, it's got to correspond to the y values you just put there. What's the 13.9? That's in April, which I represent with a 4. Yep. And the 9.4 is January, which I would represent with a 1. Yep.
Oops.
1.5. Yep. What's it mean? Ooh. What's it mean, the 1.5? I like that. Okay. So go ahead, Ben, one more time. I'll give you credit for it.
From January to April.
So hold on. From January to April, yep.
The hours of daylight increase.
I wouldn't say the hours a day. I'd put another word in there. The average. The average hours of daylight. Because that's what you found, the rate of change, the average rate of change. The average hours of daylight. Daylight increased by 1.5. What's 1.5 though? What type of units? Hours. Yep. Good. I like that one.
Doesn't it change monthly? Is it like 1.5 monthly?
On average, yes, monthly, but we don't have to.
Oh, okay.
We're just saying from January to April, on average, it increased 1.5 hours. If you want to put per month, that's fine too. Yep. We all right. That's a nice 2-pointer right there, right? 2 extra points for us. And you know what else is a nice 2-pointer here? Number 31. Our second unit together this year. Recursive formula. Remember anything about a recursive formula that I can write down here? 2 parts. We should be writing down 2 things right now. Anybody remember the 2 things you got to write down? One involves
Which one we start with?
a n minus, what's that symbolic for? A n minus 1. Previous term. So you guys right now got to figure out what the pattern is. All right, and remember, it's only a 2-point question. The pattern shouldn't be so elaborate that we're never going to figure it out. Okay, obviously it's not adding 3. So it's got to be something else. All right, so can we figure out what the pattern is to go from 6 to 9, 9 to 13 and a half to 20 and a half? What am I doing in the previous term to get to the next one? Try some stuff out on the calculator if you need to. 6, do this to it. Plus 1/2? Adding 1/2 though? Because 6 plus 1/2 is 7 and a half.
No, 6 plus half of the previous term.
Okay, so you're multiplying the previous term by.
My brain won't
No, I understand what you're saying.
like words, but that's
You're multiplying the previous term by 1.5. That's what you're doing, right? It's kind of like our 6%. We didn't use 6%, right? We used 1.06. So yes, you're multiplying the ready? You're multiplying the previous term by 1.5, and I still need something else. That's equal to, anybody remember? A of n. Yep, that's it. Any term can be found by multiplying the previous, and you're missing one other thing as part of a recursive formula. Yes. How do I write the initial term? A1, and it's already there for you. It is? Okay, that's all you need. 2 points. Here you go. As long as you can find the pattern. 2 points. Questions from you guys? Okay, we got one more to do. Now we're going to go jump to a part 3 question. Number 36 with Juan and Felipe. So how many times they won corresponding to how the practice times were. I'm only going to have time to do part A. We'll do part B when first thing tomorrow. Okay, you guys can read through part A there. Given it was practice time was long, what's the probability Felipe wins the next match? What do we already know? What's already been given to us? Oh, what's already been given to us? Okay, I'm talking about the problem, the question. Forget the chart right now. What do we already know going into this? Practice time was long. So that tells me I am not going to use all the numbers from the chart. If you know practice time was long, here's where my focus should be. I don't care if practice time was short. I already know it's been long. Okay, so now what's the probability Felipe wins? How many did he win already? 12 out of how many matches? 27. Okay, everyone see why we're just looking at that? Okay, given it was already long, so I don't look at the full table, I just look at long practice time. 12 wins out of 27 chances. We will do this one first thing tomorrow, but here are the ones I'm going to suggest you try tonight. You guys now know where the answer key and video solutions are. So 32, 26, 23, 21, 18, and 15. Those are the ones I'm suggesting to try out. I will still answer your questions about them tomorrow, but you guys got to start getting in the habit, looking up the answers yourself on Aspen and then getting video solutions if you need it. Start now.